Okay. First, let's revise whatever we have done yesterday. So remember which topics we covered yesterday? We have seen network topologies, right? What different types of LAN topologies we can use. Then we have covered different types of network devices, right? We have seen the difference between them, why we need to choose switch over bridge and hub, right? Where you can use router. Then after that, we have seen how we can create straight cable, cross cable in a lab, right? With the help of crimping tool. Yes or no?
Yes, ma'am.
Right. So today we are going to see open system interconnection model. Okay. Today we are going to see open system interconnection model. Now tell me why there is a need of OSI model. Now every one of you must be aware of OSI model, right? Have you gone through OSI model somewhere in your syllabus? Yes or no?
Yes, ma'am.
Right. So today we'll discuss what is OSI reference model, why we need that, right? And based on OSI model, how TCPIP model is designed and what is the working principle of TCPIP model as well, right? Because TCPIP is the commonly used protocol suite. Everywhere in communication, you find TCPIP used, right? So today on day 3 of your workshop, we are going to cover these two topics, OSI reference model and TCPIP model. Okay. Now see, first, now anybody knows what is the need of OSI reference model? See, ISO, that is International Organization for Standardization, created the OSI reference model as the first major attempt to inter-network various vendor-specific networks. Now, what is the meaning of this sentence? In earlier days, the networks were vendor-specific. What is meant by vendor-specific? Two different vendor computers or two different vendor devices could not communicate with each other at that time, right? So there was a need to standardize the communication process. So OSI reference model is the first major attempt, right, to standardize the communication process so that various vendor specific networks can interact with each other, right? So OSI is completely a logical model, right, designed for interoperation of different vendor network. So what OSI defined or what OSI has given? See, OSI has given a set of guidelines that developers can use to create and implement applications to run on a network. So all the applications must be open standard or industry standard, not vendor specific. Okay, that is the thing achieved by OSI reference model. Okay, now what are the benefits of this OSI reference model? Very first benefit of OSI reference model is it divides your network communication process into smaller components. So if you know how OSI works, it is easy for you to understand the communication process or a network between two systems. Means whenever you request any data, right, from one system to other, actually behind the scene, what process happens, it is explained by this OSI reference model. Then it encourages industry standardization by defining what function occur at each layer of the model, right? Means OSI has divided your communication into different layers, right? And on each layer, some protocols or standards are defined so that developers can create protocols or application based on that, and communication can be standardized, right? So it allows various types of network hardware and software to communicate with each other. So it is really necessary or important to understand this OSI reference model if you want to work into IT infrastructure domain or into networking, right? This is a basic model. So OSI has 7 different layers, right? Means entire communication process, you can say, is divided into 7 layers. And these 7 layers are again divided into 2 groups. See, total 7 layers. These are the top 3 layers of your OSI reference model, right? What are they? Application layer, presentation layer, and a session layer, right? So these top 3 layers define how the applications within the end station will communicate with each other as well as with user. Now see, whenever you access any data from the network as an end user, you need some kind of a platform where you can put your request, right? Then the system can process that request and return the or whatever data you expect, right? So application, presentation, and session layer gives user an interface, you can say, where user can interact with the system and can put the request. Clear? Then bottom 4 layers define how data is transmitted end to end. Okay, so as a network engineer, upper 3 layers will not be important for you, but yes, below 4 layers are very much important because actual transportation of data will be taken care by these 4 layers. Now, actually, each layer is going to make your data ready for transmission, right? Now, we've seen transmission media. So, actually, whenever your request is sent or whenever your data will be transmitted, transmission will be through a transmission media, right? Whether it will be wired or wireless. But what is the function of these 4 layers? These 4 layers will make the data ready for transmission. Is that clear? So these are the 7 layers which are given by OSI reference model, and your communication process is divided into these 7 layers. So now we need to understand each layer one by one. What is the function of application layer, right? Which protocols are defined on application layer? Then what presentation layer do, right? Then what session layer does? Everything. So each layer now we are going to see one by one. Okay. So any doubt in this?
No, ma'am.
Okay.
No, ma'am.
Okay. So now let's understand each layer one by one. Just a moment. Huh? Okay, so now let's see all these layers in detail. See, very first layer, or you can say a 7th layer. Okay, how these layers are numbered from application to physical. Application layer is numbered as a 7th layer, right? Then Rohini, vendor network means there are different vendors available in the IT industry. Now, what is meant by vendor? Vendor who manufactures the device, right? We have seen the hubs, switches, routers, right? So somebody manufactures them. So manufacturer of the device is nothing but vendor, right? So IBM, Cisco, Juniper, HP, right? All are the different vendors. So in earlier days, the networks were vendor specific, means HP computers can communicate with HP, IBM can communicate with IBM. But if you want communication between HP and IBM, it was not possible. Clear? What is meant by vendor networks or vendor specific networks? Okay. Now, application layer is the 7th layer in the OSI model. Then presentation layer is the 6th. Session layer is 5th layer. Transport is 4th. Network layer is known as 3rd layer. Data link is 2nd. and physical layer is the first layer. Okay, so now let's start from application layer. So seventh layer of the OSI reference module is application layer. Now remember, application layer is closest to user. Means what is the function of application layer? Application layer provides a platform or an interface where user can interact with the system and can put various requests, right? Because whenever user initiates the communication, where the communication will be initiated? On the application layer, right? So developers has to develop certain protocols on application layer so that to receive or to request different kind of data, user can put different kind of requests, right? So all applications and utilities that communicate with the network fall in this layer. Now, can you tell me one of the example of application layer utility or a software which you would normally use? See, here it is written, web browser, correct? If you want to open a website, right? If you want to search anything on google.com, where you go? You open a Google Chrome or Internet Explorer, right? Or Mozilla Firefox. What are these? These are the applications, right? Why these applications are designed? To interact with the system so that user can put a web request and receive a web content, right? So web browser is an application which works on application layer so that user can interact with the system. And if you are using web browser to put your request, then you need some kind of application layer protocol, right? To distinguish which kind of request you want to put so that what kind of data you will receive. So whenever you are using web browser as an application layer, you can say what user interface, then your protocol will be HTTP or HTTPS. Yes or no? Hypertext transfer protocol you will use to request a web page, right? So where your data will be put or request will be put by user, it will be on application layer. That's why application layer is closest to user and it gives user interface to interact with the system. Clear? What is the function of application layer? So whenever you want to send a mail, definitely which layer will come into picture? Application layer will come into picture, right? Whenever you want to transfer a file, again application layer will come into picture. So all the protocols which are used for email transmissions, files transmissions, right, web requests, everything works on application layer, right? Now below application layer, the next layer available is, see, these are all the protocols, HTTP, FTP, Telnet, right? AFP is one of the protocol, NCP is one of the protocol, right? SAP, all these are the different application layer protocols designed for different kind of application services, right? Now, below application, there is another layer available, which is presentation layer, correct? Now, what is the function of presentation layer? Presentation layer will present the data in proper format as requested by application layer. Means what? Work of presentation layer is dependent on its upper layer, that is application layer, right? So based on application layer request, presentation layer is going to format or present that data so that below layers will understand it and proper data will be given to user, right? So if you want encrypted communication, it is the duty of presentation layer or it is the function of presentation layer, right? So all kinds of encryption, decryption, encoding, decoding, compression, decompression, everything will be taken care by presentation layer. Simple example will be if you are going to put a request using web browser by using HTTP protocol, then what kind of documents you will request? Will you get a .doc file or .xls file? No, right? Whenever you put a request with the HTTP protocol, always you will get HTML document. Yes or no? So who decides this? Presentation layer decides this. If the request is HTTP, I need to present the data in the HTML format, right? Means user is going to request HTML pages, so I will present HTML pages. So definitely work of presentation layer is totally dependent on application layer request. So presentation layer will present the data in proper format as requested by application. So which protocols will work on application presentation layer? All encryption algorithms, right? All mechanisms for encoding, all file formats, extensions, everything will work on presentation layer. Now, do you tell me or can you tell me any of the encryption algorithm you know? We have many encryption algorithms available, but any encryption algorithm, any one that is known to you? So if I want a secure communication, if I don't want to send data in proper, or you can say a readable format, I can encrypt it, right? And which kind of encryption algorithms I can use? Anyone? You can write in chat box or you can unmute and tell me. Have you gone through the encryption process or different various encryption algorithms? Anyone? Yeah, cryptography is a method of encryption, and there are different algorithms available which we can use for encryption purpose. Have you heard about MD5 or you heard about DES or AES, Advanced Encryption Standard? Anyone?
Yes, ma'am.
Right. So these are the encryption algorithms which will work on presentation layer, so that if on application layer, if you put a request to get encrypted data, presentation layer will provide you data in the encrypted format with the help of different algorithms, right? Now, below presentation layer, there is a third layer, which is session layer. Now, what is the function of session layer? Session layer is going to create the session, right? It will manage the session while data is transmitted, and then after data transmission is complete, it will terminate the session, right? So to maintain a session between sender and receiver, which layer works? Session layer works, right? But remember, these three layers are operating system managed layers. Means as a network engineer, you no need to work on application layer or presentation layer or session layer, right? That will be a lookout of a developer, because different protocols will be developed on all these layers, right? So that user can properly interact with the system. So these three layers are not very much important as a network engineers, but below four layers, that is from transport to physical, are very much important, and you need to understand actually what happens in transport layer, right? What happens at network layer? What is the function of data link layer? So session layer simply creates a session, manage a session, and terminate a session, so that a proper session can be maintained, right? And user can receive acknowledgements whether my data is transmitted or not, whether I'm going to access whatever I want to access or not. So everything is managed by session layer. Even we have seen the communication type, half duplex and full duplex, right? So whether communication will be half duplex or full duplex, it will also be decided by session layer, because it is a part of creating session, managing it, and terminating it. So is that clear? What these three layers do? What is the function of application,
Yes,
presentation, and session? Okay. Now, very important layer is a transport layer, right? Now, you tell me, whenever you want to post, say any letter, right? If you want to post a letter, what are the requirements? What you should add with that letter so that your letter will be posted properly to destination? What do you need? Addresses, right? First, you need an envelope, correct? You will put your envelope letter into that envelope, right? And on that envelope, you will write different kind of addresses, correct? You will write name, You will write a full address, then you will write a PIN code, then a phone number, everything. Means you will have multiple kinds of addresses which will help your letter to be posted from source to destination, right? Now, if you compare the same scenario with your network, right? In network also, what we are doing? We are delivering the data, right? We are transmitting the data from source to destination, whatever kind of request it will be, but it is a data request, right? So in the same manner, in network also, your data needs some kind of addresses so that your data can travel in a network and can be sent from source to destination, right? Now, these different kinds of addresses will be added by these below 4 layers, right? So that data will be ready for transmission. So what is the function of transport layer now? Transport layer is responsible for end-to-end data delivery, right? So to deliver the data from source to destination, first kind of address will be added by transport layer, and you can say now my data is encapsulated. Now, what is meant by encapsulation? Encapsulation is nothing but adding headers or addresses with the data. Now, remember, application layer, presentation layer, or session layer is not going to add anything with the data, right? So on both these or on all these 3 layers, your data will be known as data only. But when your data comes to transport layer, in order to send that data from source to destination, transport layer is going to add first kind of address to it, and now your data will be converted in some different format, and that is known as encapsulation of the data, right? So encapsulates the data with transport layer header or transport layer address, and now the new term given to data is segment, right? Peer-to-peer and point-to-point. There is no difference actually. Peer-to-peer communication is a point-to-point communication, right? One peer will communicate with the other. Yes, Rohini? What do you actually want to ask? You can say either a peer-to-peer communication or you can say a point-to-point communication. Okay? Okay. So now, whenever transport layer will add one type of header with your data, then data is converted into new form, and that form is known as segment. Okay. So segment is nothing but PDU. Now PDU means what? Protocol data unit. Data with some kind of header added to it, right? So at each layer of OSI reference model, data is referenced as PDU. So what is the PDU at transport layer? Data at transport layer is known as segment, right? So whenever anybody says segment, means that data has transport layer header inside it. Is that clear? Now, why these transport layer addresses are required for end-to-end communication? Transport layer addresses are required to identify application layer service. Okay. So whenever receiver is going to receive the particular communication at transport layer, receiver should identify what kind of application layer request is there in the data, right? So to identify the application layer service or a protocol, we are going to use, or OSI is going to use, one type of address with the data which will be attached on the transport layer to create a segment. Now, can you tell me what these addresses are? These are nothing but the port numbers. Are you aware about it? Port numbers. Have you heard about it before? That transport layer uses port numbers. Now, why these port numbers are used? Port number is nothing but addressing used at transport layer, and why these port numbers are used to identify application layer service. Is that clear? Now again, there are various protocols used on transport layer to convert your data into segment. Some common transport layer protocols are TCP, that is Transmission Control Protocol, UDP stands for User Datagram Protocol, and SPX, that is Sequence Packet Exchange Protocol, right? And all these protocols are using port numbers as address to identify application layer service. And this port number is a 16-bit number. So it varies from 0 to 65535. So total 2 raised to 16 port numbers are available with you. Is that clear? What is the function of transport layer? Any doubt in transport layer? So transport layer is going to add first address, means first time your data will be encapsulated, and the address added by transport layer will be port number definitely, and those port numbers will be used to identify application layer service, right? Now once transport layer has encapsulated your data, data will be handed over to the next layer, and that next layer is nothing but network layer, right? Now what is the function of network layer? Function of network layer is to find best shortest path to send data from source to destination, right? So there might be number of paths available to send your data from one location to other. So network layer will find out best shortest path. Now to find out best shortest path, again network layer will need some kind of addresses, right? So to find the best network layer or to find the best path, network layer again adds second type of address with the data, right? Means your data is again encapsulated. At transport layer, data already has one layer in it or header in it. Now the second header will be added and your segments are now converted into packet. So what packet has? Packet has network layer header as well as transport layer header, and inside that there will be application layer data, right? So now to add these addresses so that best shortest path can be found, right? Protocol used will be IP or IPX, right? Again, there can be different network layer protocols available. Some of the examples of network layer protocols are IP, IPX, and DDP. And all these protocols are going to add the addresses with the data so that best shortest path can be found. Is that clear? So what network layer is doing? Network layer is adding the second type of address with the data so that shortest path can be found and your data can be sent from source to destination with the shortest path, right? And to add those kind of addresses, protocols used on network layers are either IP, IPX or DDP, right? Now, to find out the best path or which device works on IP addresses, we have seen the devices, right? Router works on IP address, right? Router needs IP address for sending the packet or sending the data. That's why we say router works on network layer, because router needs IP address to send your data from source to destination. And that's why we say router works on network layer. Is that clear? So if somebody asks you which device works on network layer, your answer will be router works on network layer, and that's why routers are known as layer 3 devices. Clear everyone? Because it is the function of router based on IP address, find out best shortest path. Now how router does that, we are going to see, right? If you go for CCNA, definitely that will come in your syllabus. How router use that IP address to find out best path. But remember, Router works on network layer to find out best shortest path based on IP address. Okay. Now, by finding the best path, your packet will reach from source to destination, right? But once that packet reach to destination, then it must be find out on that network to which host should we deliver this packet, right? On that particular network, there may be n number of hosts available, but out of those n number of hosts, the data should be delivered to a particular host on a network. So who will do this duty or function? Data link layer will do it. It will deliver the data to particular host on the network. And now again, to deliver data to particular host, again we require third type of addresses. So data link layer is going to add third type of addresses with the data. So data is again encapsulated, and now your data is converted into frame, right? So on application layer, it was data. At transport layer, data is converted to segment. Then on network layer, segment is converted to packet, and on data link layer, now packet is converted to frame, right? Now for converting packet into frame, what data link layer is doing? Data link layer is adding again one kind of address with the data so that data can be delivered to particular host. Now, another function which will be performed by this data link layer is error checking, because up to network layer, no layer checks the data for errors, right? So before actually sending the data in the network, it is necessary to find out whether data is error free or it has some error. So who does that duty or function? Data link layer does that with the help of cyclic redundancy check. So once data link layer adds header with the data, right, means whenever your packet is converted to frame, data link layer will run CRC algorithm on the data, and it will calculate one checksum, which is known as frame check sequence, right? And that frame check sequence will be put with the data as a trailer. Okay, means in transport layer, only header will be added. In network layer, also header will be added, but data link layer is going to add header as well as trailer. In header, there will be addresses available to deliver the data, and in trailer, there will be FCS, that is a checksum, correct? So output of cyclic redundancy check will be kept as a trailer in the FCS field, so that at the receiving end, whenever receiver receives the frame, again receiver will run the CRC and it will match whether both the values are same or not. If both the values in FCS field are same, data is considered error free. If the values differ, data is with errors, right? And if the data has errors, data will be dropped. Clear? So data link layer does two functionalities. One, it will add one type of address so that data will be delivered to particular host. And second, data link layer is going to check the data for errors, right? So which protocols will work on data link layer? So all the LAN and WAN protocols which are used either to establish LAN or to establish WAN will work on data link layer. So one of the example of protocol working on data link layer, anyone? We have seen what is the most common protocol for LAN communication. That protocol will definitely work on data link layer, right? Anyone? Which is the protocol we used to establish LAN? Yesterday we have seen this in topologies section. Or you can tell me what are the different LAN protocols available so that you will understand. Ethernet, yes, Ethernet is one of the LAN protocol, right? So Ethernet works on data link layer. Now, other than Ethernet, you have AppleTalk, token ring, yes or no? Then you have PPP, HDLC. in the WAN category, right? So ATM, yes. So all these protocols will work on data link layer, right? And the function of these protocols will be to deliver the data to particular host on a network, right? So if you are using Ethernet protocol on data link layer, then what kind of addresses will be used for data delivery? Tell me. What is the address used by Ethernet? Now you know that. Yesterday we discussed it, right? The way IP protocol requires IP address. What address is required by Ethernet? If the communication is Ethernet, it will be MAC address, yes or no? Physical address, right? So if on data link layer, Ethernet protocol is used, then to deliver the data to particular host, what kind of addresses will be used? Physical address or MAC addresses. So clear? What is the function of data link layer? Means 3 different addresses will be added at 3 different layers by OSI model. First address is added at transport, second address is added at network, and third address is added at data link. So now can you tell me which devices will work on data link layer? If you consider protocol used at data link layer is Ethernet and the address used by Ethernet is a MAC address. So can you tell me which devices will work on data link layer? Anyone? The way router works on network layer. Why router works on network layer? Because router needs IP addresses to find out best path or to forward the packets, right? Similarly, an IP address is an address used by network layer. So we say routers work on network layer. So in the same way, can you tell me which devices will work on data link layer? Yesterday we discussed those devices. Yes, it will be switch or bridge, right? Because switch and bridge both requires MAC addresses, right, to forward the data. And if they require MAC addresses, means bridges and switches both will work on data link layer, and those are known as layer 2 devices. Is that clear? Now, why switch is known as layer 2 device? Because it works on MAC address, and MAC address is a property or address of data link layer. That's why switch or bridge is known as data link layer or layer 2 devices, right? And the final layer in the OSI reference model is nothing but physical layer, right? So once all the types of addresses are there in the data, then finally physical layer is going to convert this data into bits and it will be sent from the transmission media. So transmission media either can be wired or it can be wireless, right? So from wired media, you can use either copper or fiber cables, right? Okay, on network layer, which protocols you can use? It will be IP or IPX or DDP, right? Any of the protocol. Majorly or most commonly used protocol is IP, correct? Clear? Which protocol you can use on network layer? So again, see, Ethernet is a protocol which works on physical layer as well, because yesterday, whatever cables you have seen, that is a straight cable or a cross cable, all these are known as Ethernet cable. So Ethernet gives physical cabling standards as well. So that's why you see Ethernet works on both layers, physical layer as well as data link layer. Now, what is the function of physical layer actually? Physical layer just transmits the data from source to destination. So now can you tell me which device will work on physical layer? See, all cables, connectors will work on physical layer, but what is the device or which is the device which works on physical layer for data transmission? Tell me. Which device works on physical layer? Yes, it will be repeater. It will be hub. Yes or no? Because hub repeater does not understand anything. They just transmit the data as it is, right? So all these are working on physical layer. Clear? What is the function of physical layer? And hub works on physical layer. So it is known as layer 1 device. Clear? How your OSI model works? What is the function of all these 7 layers? Any doubt, anyone in this? Now see, this diagram will show you how your data is encapsulated, right? See, on upper 3 layers, data is as it is known as data because there are no headers in it. No, physical layer does not require any address because function of physical layer is to just transmit a data. But if you want to transmit a data from physical layer, all 3 addresses must be there in the data, right? There has to be a transport layer address, there has to be a network layer address, and there has to be a data link layer address, right? No separate address is there on physical layer, but to transmit data from physical layer, all these 3 addresses are required. Clear, Rohini? So physical layer does not require any additional addressing, right? Physical layer is only converting data into bits and transmitting it. But to convert the data into bits, it should be proper. Proper means it should have all 3 addresses inside it. Okay. So see, on upper 3 layers, the encapsulation is, no encapsulation is there with the data. So data is termed as data only, right? When data comes to transport layer, now it is a segment, correct? Because it has a header. Again, transport layer will hand over it to network. So it has again one header. So it is packet. Then packet will be handed over to data link, right? Now see data segment packet. Now you have a frame header and a frame tailer. Now this is the complete data. And now physical layer is going to convert this data into bits and will transmit it from your transmission media. Clear, everyone? How data encapsulation is? Any doubt? Okay.
No,
Okay. So now see, OSI is very generalized model. Okay. It has given a reference. How developers should develop a protocol, right? How communication should be in a network, right? So anybody can develop any protocol, but that has to follow this layer approach, right? So based on this OSI model, number of vendors or number of organizations have developed their own models for communication. But one of the model which is accepted by internet community is a TCP/IP model. Okay, so now let's discuss TCP/IP model, which is designed from this OSI model and it is accepted by internet community. So nowadays, whenever you see communication in a network, that communication is based on TCP/IP only. Okay, so now let's see what is TCP/IP model. Okay, now TCP/IP model is also known as DoD model. Now, who developed this TCP/IP? Department of Defense USA has developed this TCP/IP model or DoD model during Second World War for intercommunication of their own computers. Okay, later on, internet community has accepted it and everywhere now it is a standardized model for communication, or you can say it is a standard set of protocols which are followed or used in network communication. Okay, so now it is accepted by internet community. And who works on this development of TCP/IP? There is an organization known as INA. Internet Assigned Numbers Authority is one of the US based organization which works on development of TCP/IP. Okay. Now again, it is designed with the reference of OSI reference model. right? But the difference is what? In OSI, there are 7 layers, but TCP/IP has only 4 layers. But actually, these 4 layers are combination of 7 layers, right? So you can say 7 layers in OSI are represented as 4 layers in TCP/IP. So which are the 4 layers TCP/IP model has? Fourth layer or the top layer is application layer. Then third layer is a host to host layer. Then you have inter-network layer and the network access layer, right? So these 7 layers are combined or represented in 4 layers by TCP/IP model. Now see, this is the comparison, okay? Upper 3 layers, which are OS managed, are combined into one layer and named as application layer in TCP/IP, okay? So actually these are 3 layers, but now it is represented as a single layer. Then transport layer is as it is, right? So it is as it is, only the name is changed. Now in TCP/IP it is known as host to host layer, okay? Then network layer is also as it is, only the name is different. In TCP/IP it is known as inter-network layer. And below 2 layers, that is data link and physical, are combined into one layer and termed or named as network access layer, right? So actually TCP/IP is a combination of all these 7 layers represented in 4 layers. Is that clear? Comparison of TCP/IP and OSI. Actually, you can say they are same. Only TCP/IP has 4 layers and OSI has 7 layers. Correct? Now see, when you say that you are using TCP/IP model for communication, means you are using some of the protocols given by TCP/IP. Okay, TCP/IP model. So TCP/IP model has given protocols only for 3 layers. This is very important. Okay, TCP/IP model has protocols working on application layer, protocols which work on transport layer, and protocol which works on network layer. But network access layer is independent of protocol suite. Means there is no strict limitation in TCP/IP that only these protocols will be supported for TCP/IP communication. So any network access layer protocol, means all LAN and WAN protocols are supported by TCP/IP. So TCP/IP model is given only 3 layers protocol. Okay, they have defined certain application layer protocols. So you have to use those application layer protocols only if you are going for TCP/IP communication. Similarly, they have defined transport layer protocols. So definitely each and every application layer protocol will be based on same transport layer protocol which are defined by TCP/IP model. Again, they have a strict protocol defined on network layer. So we have to use that protocol only for TCP/IP communication. But there is no restriction or limitation for network access layer protocols. Is that clear? So can you tell me what are the application layer protocols? You can name any protocol that is given by TCP/IP and which work on application layer. HTTP is one of the application layer protocol. Yes or no? Or HTTPS? Both the protocols are designed for web access. Correct? That belongs to TCP/IP protocol suite. Again, FTP, TFTP to transfer files between the system are application layer protocol defined by TCP/IP. Then you have SMTP, POP, IMAP. All these protocols are for sending and receiving mails, right? SMTP is used to send emails. IMAP and POP will be used to receive the emails. Then there is one of the protocol known as DNS, right? To resolve fully qualified domain name with the IP address and vice versa. See, whenever you access anything in the internet, by default, you access it with name, right? You access www.google.com. But actually, google.com has one IP address, but we don't know that, right? So who resolves that? DNS service does that for us, right? DNS is going to resolve this FQDN or fully qualified domain name with the IP address. So again, it is an application layer service defined by TCP/IP. Then there are two protocols, Telnet and SSH. Both these protocols are used for remote access, right? Whenever you want to access any device remotely in a network, you can either go for Telnet or you can go for SSH, right? Again, one of the important protocol in network is DHCP, Dynamic Host Configuration Protocol. Why this DHCP is used? To assign basic parameters like IP address, subnet mask, default gateway, DNS server, right? Automatically to system so that a system can be part of network. So these are some of the examples of application layer protocol. So there are a lot of protocols available which can be used for various services, but these are some of the well-known services working on application layer and given by TCP/IP protocol suite. Is that clear, everyone? Any doubt in this? Now, function of application layer,
No, ma'am.
right? Like OSI, nothing different. Here also application layer is going to provide user interface, and all these protocols are doing the same thing, right? They are giving some mechanism so that user can put a request for the data, right? Then the next layer is what? Transport layer, correct? So on transport layer, two protocols are defined by TCP/IP. One is a TCP protocol, that is transport or transmission control protocol, and second is a user datagram protocol, right? Now, all these application layer services or protocols either use TCP or UDP mechanism for transportation. Okay, so all these application layer protocols are either based on TCP for transportation or based on UDP, right? And both these protocols use port numbers as address to identify application layer service. So this is the common part between TCP and UDP, that both uses port number to identify application layer service. But definitely these are two different mechanisms of transportation, right? So based on requirement, either you can choose TCP mechanism or you can choose UDP mechanism. Again, you know, port number is 16-bit, right? So available port numbers are 02655535. Now see, out of that, 021023 are known as well-known port numbers. So what is meant by well-known port numbers? These port numbers are already assigned to any particular service by INA, right? INA has already assigned these port numbers to particular services. So these are known as well-known port numbers. And above 1023, all are known as dynamic or random port numbers, right? Because whenever your system or as a client, whenever you request anything from a server, right, from your system also, one port number will be used, right, to send a request, right? And on server, one port number will be used to accept the request. So remember always, destination port number or a port number from a server will be a well-known port number because we will be accessing some well-known service from the server. But from client, always any dynamic port number will be opened, right, for communication. So now see, these are some of the application layer services, right? Some of them are based on TCP and respective port numbers are written, right, in this chart. HTTP is a TCP based service and uses port number 80. So as a network engineer, you should know this, at least for well-known services, okay, or well-known protocols. whether they use TCP mechanism or they use UDP mechanism, and on what port number they work, right? So HTTP works on port number 80. Actually, it will be required for you whenever you use or work in a security domain, or whenever you will be in the firewall configurations. At that time, this must be known to you, right? Because you will get a request that open a particular port number or allow particular service. So at that time, you should know, right, which application layer service uses which transport layer mechanism and what is the port number for it. So see, HTTP uses 80, HTTPS uses 443, SMTP is 25, POP3 110, IMAP 143, Telnet 23, SSH 22, DNS 53, and FTP uses port number 20 and 21. All these application layer protocols are based on TCP, but some of the protocols are based on UDP, and which are they? TFTP, then DHCP client, DHCP server, DNS, SNMP, and NTP. So all these are the UDP based services, right? But not only these protocols are there in application layer, there are n number of protocols, right? And you can find out this information on website of INA, right? If you search the website of INA, you will get detailed information about this. Or if you are using a Windows system, in your system itself, all these TCP based services with their port numbers, all the UDP based services with their port numbers is available in the C drive, right? So you will find out that where you can get all this information in your Windows machine, right? It is there, right? Many different application layer services are mentioned, and which application layer service uses TCP or UDP, it is also mentioned there. Which port numbers are used by those services, it is also mentioned there, right? So just find it out and tomorrow just tell me, okay? If you get, otherwise I will tell you where you will get all these information. Is that clear? Any doubt till here? Which application layer service uses TCP or UDP? Okay. Now, because TCP and UDP are two different mechanisms, you need to understand what is basically the difference between TCP and UDP. So see, very first point, what is written? TCP is a connection oriented protocol and UDP is connectionless. Now see, what is the meaning of this? Whenever any TCP communication is going on or is going to start, first, sender and receiver will undergo one process known as connection establishment. Okay, until and unless connection is established between source and destination, data cannot be sent. So every time before actually sending a request, TCP will establish a connection with the mechanism known as three-way handshake. Okay, you will learn this detail or in detail if you go for CCNA, right? How this three-way handshake is done, right? What is the purpose of this? But remember, TCP, because it is a connection-oriented protocol, it will undergo three-way handshake. It will first establish the connection and then it will send the data. Okay, but on the contrary, UDP is connectionless, so there will be no connection establishment. Directly your data will be sent from sender to receiver. Okay, then second point is what? TCP maintains flow control. Now, what is mean by this? TCP maintains flow control. See, if you want to send 10 bytes of data, right? Now, TCP is not going to send all those 10 bytes together, right? That 10 bytes will be broken into, say, smaller segments, say of 1 byte each, right? So, TCP will maintain flow control means based on receiver, how much quantity receiver can receive, accordingly, TCP will adjust how many bytes I should send simultaneously. Whether I should send 1 byte of data, whether I should send 3 bytes of data together, whether I should send 5 bytes together, right? So this is what a flow control is. If receiver is ready to receive 5 bytes, sender can send 5 bytes. If receiver cannot receive 5 bytes, then sender will adjust according to receiver. This is what flow control is. So TCP is going to maintain the flow control, but UDP will not do that. UDP will not care whether receiver is receiving it or not. UDP will continuously just send the data. So that's why it is said UDP does not maintain any flow control. Okay. Now, third point is what? TCP needs acknowledgements. So whenever TCP data is sent, sender will wait for acknowledgement, and after receiving acknowledgement, next data segment will be sent. Okay. So that's why TCP is a reliable communication. Means sender always know whether whatever I have sent till now, is it received by receiver or not. Why? Because of these acknowledgements. And that's why on transport layer, TCP is known as reliable protocol. But actually, it is the work of session layer, right, to maintain the reliability. But TCP has taken this extra overhead. So if the communication is TCP, session layer does not have any work, right? Because TCP is maintaining it itself, right? It is waiting for acknowledgement, and then it is sending the next bytes of or next amount of data. But UDP does not have any acknowledgement, so it will continuously just send the data. If receiver is ready to receive, data will be received. If receiver is not ready, data will be dropped. And that's why on transport layer, UDP communication is known as unreliable communication, right? And because of flow control mechanism, connection establishment and acknowledgement, TCP communication becomes slow and UDP communication is a faster communication. So now remember, it is completely dependent on developer which develops application, whether developer wants this application to be TCP based or UDP based, and how it will be decided based on for what purpose this application will be used. Now remember, if your application will be used for voice over IP communication or video conferencing or live streaming, broadcasting anything, right? It cannot be TCP based, because if you make that application TCP based, it will introduce delay in the communication, right? So all the real-time applications are UDP based, remember. But whenever you are going to access any static data, that application can be TCP based, right? So that's why if you see here, see HTTP, HTTPS, all these are the TCP based service. So these are reliable communication. But whenever we are accessing anything using HTTP, means we are accessing a content which is already present on any web server or in any database. So it is not a real-time request. So it can be TCP based. So it will be decided by developer, right? Whether it will make the application based on TCP or it will be based on UDP. And all real-time applications will be UDP based. Is that clear? What is the difference between TCP and UDP? Now in CCNA, you will learn all these things in detail. Means what is the mechanism of flow control, right? What is the windowing? What is the difference between these two headers? Everything in detail, right? But for now, just to understand what is the difference between TCP communication and UDP communication, remember these points. Okay, clear everyone? So on transport layer, you have two protocols and this is the difference between them. So can we move to network layer now? Right? So now see. The next layer in TCPAP model is what? It is a network layer, right? So which protocol is used on network layer? It is IP, right? Protocol used on network layer is IP and PDU at network layer is packet. Correct? Network header plus segment. Now, what is the function of network layer? Packet forwarding and packet filtering, finding best shortest path based on IP address, right? Now, why IP address? Because TCP/IP uses IP, Internet Protocol, as a protocol on network layer. And now for addressing of IP, we have two schemes. One is IP version 4 and the other scheme is IP version 6. Right now we have both simultaneously implemented in a network, right? But future of network is going to be IP version 6 only, right? One day IPv4 will be completely eliminated and you will see everywhere only version 6 addresses, right? So right now routers can use V4 as well as V6 addresses to find out best shortest path for TCP/IP communication. Now, transport layer must understand what is the protocol used on application layer, right? And to identify that, transport layer uses port number. Similarly, network layer should also understand which protocol is used on transport layer, whether it is a TCP communication or whether it is a UDP communication or the communication is happening only on network layer, right? So to identify that, IP uses protocol number. So when you study IP header, you will find one field in that IP header, which is known as protocol number. And based on that protocol number, network layer will identify transport layer protocol. So remember here, if on transport layer TCP protocol is used, you will find out protocol number 6 in the IP header. So if you find protocol number 6 in the IP header, you must understand that on transport layer, segment created with the TCP protocol. Similarly, if you find protocol number 17 in the IP header, you must understand that on transport layer, UDP protocol is used. Is that clear? And now when you say IP is not one protocol, but it is a suite of protocol, right? Means IP has number of protocol inside it. Now, one of the important protocol which comes under IP is ICMP, Internet Control Messaging Protocol. You can say it is a core component of IP which is used as a messaging service. Now, every one of you must be familiar with two utilities, ping and traceroute. Yes or no? Somewhere you must have used this. You have used ping command and traceroute command. Yes or no? Right? What this ping does? Ping checks the connectivity, right? Whether source and destination are connected to each other or not, whether we have connectivity or not, right? So ping does that. So ping uses this ICMP protocol, and these two are very much important utilities for network engineers to troubleshoot the connectivity issues, right? And these two uses ICMP, and ICMP is core component of IP because it is messaging protocol. So it will give you error messages as well, right? So ping and traceroute will be two utilities which we work or which we will use on network layer to find out connectivity for IP communication. Is that clear, everyone? Now, details about again IP and ICMP will be there in your CCNA syllabus. But for now, is it clear? What is IP and what is ICMP? Overview of that. Any doubt in this? If you have any doubt, you can write in chat box. Right? Means you have certain protocols defined on application layer by TCP/IP, right? You have definite protocol on transport layer, correct? TCP and UDP. Similarly, you have a protocol suite or a number of protocols on network layer which comes under IP, right? So IP is one of the major protocol which we use on network layer if we are using TCP/IP communication. But network access layer is independent. So either I can use Ethernet, right? Or I can use ATM or any protocol, correct? But again, layer 2 header or network access layer header also has one field to identify network layer protocol, because each and every layer must understand which protocol is used at upper layer for communication purpose. So again, you will have a type or a protocol field in your Ethernet header to identify which kind of communication is there on the network layer. Whether we are using TCPAP protocol suite or we are using SPX IPX, because Ethernet is supported by TCP/IP, Ethernet is supported by SPX IPX as well. Is that clear? As network access layer is independent of protocol suite. Okay, so now see here. This is the encapsulation, TCP/IP encapsulation. So whenever you have data, it will be on application layer. Then on transport layer, there will be, suppose, TCP header, or it can be UDP header. Then on network layer, there will be IP header, and then you will have a frame header, that is Ethernet header, correct? So it is your network access layer encapsulation, right? Now see, this is for your understanding how your data is encapsulated and how it is decapsulated. So see, in one picture, you have a sending host, and in another picture, you have a receiving host, right? So whenever data is sent, request will be put on the application layer, right? Then that application layer request will be converted to TCP segment. Then TCP segment will be converted to IP datagram. Then IP datagram will be converted to frame, and finally frame will be converted to bits. Means data is encapsulated at each layer whenever data is sent. But at the receiving end, bits will be received. From the bits, frame will be created. Then the header will be removed. Means data is decapsulated. So from frame, IP datagram will be created. Then network header will be removed. Then TCP segment will be there. Then TCP segment will be removed. And then receiving host will recognize the application layer request, right? So whenever your data will be sent, it will be encapsulated, but at the receiving end, data will be decapsulated, right? Receiver is going to remove headers one by one so that it will check the application layer request. So is that clear, everyone? How your data travels in a network? At the sender end, data is encapsulated, and at the receiver end, it is decapsulated. Yes, Rohini, you want to ask something? Now I'm going to show all this process in simulator to you, right? So that you will get the clear understanding of it. But theoretically, is it clear? Rohini, you raise the hand. You want to ask anything? You can write in the chat box or you can unmute yourself. Are you writing in a chat box, Rohini? Encapsulation means what? Encapsulation is nothing but adding headers, right? Whenever you will send a request from application layer to physical, each layer is going to add its own header in it, right? Transport layer, when will add a header, data will be encapsulated data, and what it is known as segment, correct? Then network layer is going to add its own header. Again, your data will be encapsulated, and what it will be known as packet, correct? Then packet will be handed over to data link. Again, one encapsulation will be there, correct? And then your data will be known as frame. So at each layer, some of the headers will be added with the data, and your data is known as encapsulated data. Is that clear now, Rohini? And at receiving end, what will happen? One by one, each header will be removed so that receiver will get actual application layer request. Clear? So now let's see all these things in a simulator so that it will be clear to you. Okay. So now see, this is a Cisco packet tracer, right? This is one of the simulator that you can use for all of your practicals of CCNA, right? If you see here, there are a lot of devices available. All these are nothing but the router models. Then if you click on PCs and devices, you have multiple options. You have PC, laptop, server, multiple devices. Again, you have some cards, right? Then you have some connections, that is cables. See, different type of cables are available here. You have a straight cable, you have a cross cable, right? You have a console cable that we have seen yesterday, right? So different types of cables are also available there. Then these are again miscellaneous devices, clouds, right? Multiple things. So now let's create here one basic topology or a LAN, right? Now to create a LAN, either we can use hub, right? Or a switch, right? So see, first I will show you if I will use hub. Now this is a hub. I will give name to it as hub 1, okay? Now I will use another hub, suppose, right? Hub 2, right? Now I will connect some of the PCs to it, to this hub. So see, this is my PC 1. Then say PC 2, 3, 4, 5, 6, right? Suppose I have 6 users connected in this hub. Now this is entire one LAN, right? Now see, I have taken a cross cable to connect these two hubs together. Now why cross cable? We have seen yesterday, because two similar devices, whenever you want to connect two similar devices, you have to go for cross cable. And now this green indicates what? Connection is up, because it is a plug and play device, right? No need to configure anything. Now let's connect PC to hub with the straight cables. See, so all these are the interfaces, fast Ethernet interfaces. I'm going to connect my PCs to it, right? Similarly here as well. See now, okay? Now, if I want communication between all these 6 hosts, then all these 6 hosts are already having physical addresses or MAC addresses. See, I'll show you. On config, on this fast Ethernet, this is the MAC address of the system. But for communication, I need to assign certain IP addresses to them, correct? So let's assign IP addresses like this. Say this IP will be 1.1, right? This PC1 will have IP address 1.1. PC2 will have IP address 1.2. Then 1.3, 1.4, 1.5. This means I'm just writing the notes here just for understanding that these PCs are having these IP addresses. But now you have to assign them, correct? So to assign the IP address, just click on the PC, go to desktop and IP configuration. So just give IP address and use tab. So there will be a subnet mask. Now tomorrow we will see why there is a need of subnet mask with the IP address, right? Because tomorrow's session we are going to cover basics of IP addressing. So today I'm just assigning the IP address with subnet mask. Similarly on PC3, let's assign the IP address. On PC4 as well. PC5 1.5 and PC6 1.6. Right? Now see, if I want to check the connectivity between all these systems, what I will do? I will go to command prompt and simply I will use ping command, correct? Now, when you use ping command means you are sending ICMP packet. Now, ICMP works on network layer, right? It comes under IP category, means you are not using any application layer utility here, but your communication will be only on network layer. So see, I will show you. See, 1.2 is reachable, correct? Similarly, if I check 1.3, it is also reachable. Then 1.4 is reachable. Yes, all PCs same subnet address because hub is a LAN device and all PCs are part of one LAN. So one LAN is one network, right? So we have to assign same network IP addresses to them, compulsory. Clear? Now see. Now same thing I will show you with simulation. Okay, just see now. I will start simulation and now I will give command ping 1.2. See now. ICMP packet is generated, correct? Now if you see what hub is doing, hub is broadcasting it, right? Now this hub is also going to broadcast it. So everybody is receiving that. Yesterday we seen this, right? PC2 has received it and has sent the reply. Now see, this is the encapsulation of all layers, right? See here. Can you see these headers? Right? This is how your data is encapsulated. See. So every time what hub is doing? Hub is broadcasting, correct? So everybody is receiving that. Is it clear now? Why hub has a single broadcast domain? Because every time, though the communication is between PC1 and PC2 only, but it is sent to everyone. Clear, everyone? Right? Now see, if you don't want this, that this communication should not go to this hub, what you can do? You can remove this cable and you can add bridge here. See, I will remove this cable and instead of connecting them directly, I will have a bridge. See, this is a bridge, right? I will use bridge and I will connect these two hubs in a bridge. See now. Now I again cannot use straight cable. I need to go for cross cable, right? See now. Let the ports green, right? And then we'll try to communicate. And I will show you. You will see all the headers as well, right? All layers, encapsulation, transport layer, network layer, as well as data link layer. See now. Now again, say I will ping 1.3. See, if I open this packet, can you see this 3-layer encapsulation? Right? Layer 3, layer 2, and layer 1. Because we are using ICMP here. Correct? See, it is sent to hub. Now one of the copy will be sent to bridge. Right? Now right now bridge does not know any MAC addresses. So one time it is going to forward it to other hub. Correct? Meanwhile, PC3 has sent the reply as well. See. Again see. Right? But now whenever reply comes, now bridge is not going to forward it to hub 2. Yes or no? Now see, for next consecutive packet, communication will not be sent to this second hub. Is that clear, everyone? What we have learned yesterday?
Yes, ma'am.
Time to learn the MAC address, bridge will forward it. But now if you want to replace both this bridge and hub, what you can do? You can simply add switch in this topology, right? So see now, I will remove all these and I'm going to add one switch in the topology. See, all these are the switches. So I will add one 2960 switch. See. This you can check in real time as well with the help of one application known as Wireshark, right? If you want to check all these headers or layers, right? How your data is encapsulated, you can capture the packets using Wireshark and you can check it. Now again, see, I'm going to connect all these PCs in single switch because this switch is a 24 port switch. So no need to use multiple devices. I can simply use only one switch and I can connect all my PCs to that switch only. Now again, all these PCs are part of LAN, correct? Now this we have connected and wrong port. So let's correct it. Okay. Let all the ports green and then we'll see. Again, one time to learn the MAC address, switch is going to broadcast the data. But once the MAC addresses are learned, switch will not forward it again. Then switch will do unicast communication only, right? See now. Now if you try to ping 1.5, so see. One time it will broadcast it, correct? But now when reply comes, it will be unicast, correct? Now there is no need to forward data to all other PCs. Clear everyone? Difference between hub, bridge and switch with the help of simulation. Any doubt? Now let's add one server in this topology, okay? And we'll use that server as a web server, okay? Means we are going to access web page from this particular server, okay? See now. Say this is my web server. So let's assign one IP to it. Say it is 1.1.1.10, for example. This server is a part of LAN and I have assigned IP address 1.10 to it. And HTTP protocol is configured on this server. And now you know HTTP uses TCP, correct? So we'll see everything, connection establishment phase, right? And all 7-layer encapsulation. Because whenever you request website or web page, means you will put request on the application layer. When you say ping, your communication is on network layer only, right? But when you put a request for HTTP, your communication will begin at application layer, right? So now let's see. We have IP address assigned. Now once this port is green, that is forwarding, we will access this server from the PC, okay? Okay, now see. Again, I will start the simulation. Now I will open the browser and put here request http:/1.1.1.10 IP address. See now. Now very first packet you can see is a ARP, right? Now why ARP is needed? Again, you will learn in CCNA, right? But remember, always any communication will start with ARP, right? Address resolution protocol to resolve the MAC addresses. Now see, HTTP packet is not generated right now. Which packet is generated? TCP packet is generated if you see here, right? It is a TCP packet and it is for connection establishment, right? It is not directly HTTP request. See now. First, client and server is establishing HTTP connection and now HTTP packet is generated. Now see, you have all 7-layer data in it. See, this is layer 2 header, layer 3 header, layer 4 and application layer request. See now. Now the data is sent, received. Now it will send reply, correct? See now, if you open a browser, see, web page is open, means Whenever you open a web page, behind the scene, all these things will happen. Is that clear? Any doubt? How data is encapsulated in OSI and TCP/IP? Right? This you are going to see in detail if you learn CCNA, right? But now I think you have the idea how encapsulation is, right? What headers will be added with the data, right? And how TCP established the connection with the three-way handshake mechanism. So now anybody has any doubt in it? If you have any questions, you can ask. Understood? Everyone? What is OSI? What is TCP/IP? And how OSI TCP/IP works? Right? So you have now one homework for today, right? You have to tell me tomorrow where you can find, right, all these TCP services available in the Windows machine. Okay? What is the location for that? You're going to tell me this tomorrow. Okay? So if you don't have any